thing that makes today different is dun 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 dun, the inequality. That's it. Now, if that had been an equal sign, what would be the answers? 4 and negative 2. And you're right. Let's see, that would be a positive x squared. It would look something like this, where it crosses at 4 and negative 2. And you already know that. If you know how to graph these things, today is not hard. Okay? If you know how to graph these things, today is easy. Because today, here's the thing. Instead of telling me where it crosses, you have to tell me, like for this one, where is the function greater than 0? Well, if you know how to graph it, then just plot those and you say, well, this is greater for less than negative 2 and greater than 4. That's where it's above, yeah. Less than negative 2, greater than 4. If you don't want to graph it, which you are going to need to know how to graph these for the test, so that's the ideal way. But if you don't want to graph it, then here's another thing you can do. We actually did something like this in chapter 2. The zeros of the function are the only possible places, as you can see from this graph. And when it crosses the axis, that is the only way that it can go from being greater than or less than 0, or it can change. So if you want, just make yourself a number line. Negative 2, 4, and you just need to test those intervals. What's the number between negative 2 and 4? 0. Plug 0 in. Negative 4 times 2. What's that? Negative 8. Is negative 8 greater than 0? No. This interval did not work, and you could punch in a number less than negative 2 greater than 4, and those would work. And you could do it like that without ever graphing it. And be like, oh, look, it has to be less than negative 2 and greater than 4. Either way will work. I personally think graphing is the easier way, but there will be problems where that's probably not the case. So, try your number line. Now, today's lesson. That's actually it in a nutshell. That's what we're doing. The only thing is, there's one other way, without actually crossing the axis. In other words, without making this an equal sign, there is one other way that a function can go from above the axis to below without crossing. How is that? Negative sign where what? Oh, no, because that would still apply. You could still plug them in, get 0. But without crossing the axis, what's one other way you can flip from above to below without crossing? What's that? That's what she was saying with flipping. But you could still plug it in. The other way is if you have an asymptote. If you get a 0 in the bottom, for instance, let's say this one had an asymptote here. Your function might have been up here, and then all of a sudden it's down here. Well, that's not drawn very well. Right? It went from positive to negative without crossing the axis. Now, what gives us vertical asymptote? 0 in the bottom, right? The only two things you have to do today are set the function equal to 0, and if it has a denominator, set the denominator equal to 0. And for all those values, you'll need to just check your intervals. Let's do some. This probably sounds like German until we do one. Let's just do this one first. Look at the graph. Now, this looks complicated. What do you say we just put all this over here and compare it to 0? Because when you're comparing it to 0, you can just look at if it's above or below the axis. So if we move that stuff over with subtraction, in fact, that's what it's done up here. Now, are we looking for above or below the axis? What's the inequality? Above or below? Above. Where is that thing greater? Above the axis. Well, it might be kind of hard to see the numbers from there, but yeah, negative 6. So it looks like negative 1/2. And what's that, 1 to infinity? That's where it's above the axis. That's negative 6 to negative 1/2. Why am I using brackets? Because it equals. There's an equal sign on the inequality. 1 to infinity. And that would be the answer to that question. That is where it is. Or, this is how you're going to be doing most of them all day. Well, I won't get into this. If you see a graph, just do it like that. That's the easiest way to do it. Questions about where those answers came from. It might have said less than. If it had said less than, well, that would be negative 6 to negative infinity and between 1/2 and 1. Negative 1/2 and 1. If it had been less than, you just look below. Questions? I don't know that I have another one. Sure. Here's so many questions. What? That is my answer. And that came from, if I were to rewrite this, it would look like this. Except it would be, if I moved these over, it would be this, right? Greater than or equal to 0. Greater than 0 on a graph is everything above the x-axis. So I'm looking at my graph and saying, where is my graph above the x-axis? Between negative 6, it looks like, and 1/2. And then from 1 to infinity. They have brackets because there's an equal sign. If this equal sign wasn't here, they'd all be parentheses. Other questions? Skipping ahead. All right. All right. If these were equal signs, you would know what to do. Pick one. Actually, I'll just pick one. Number 3. What's going to make 3 equal to 0? All right, I'll give you a second. That's very good, though. 7 to negative 3. Without graphing, I still think graphing is the easier way, but without graphing, here's all you have to do. Find what's going to make it equal to 0. In this one, it's negative 3 and 7, and just test your intervals. Okay? What's the number between negative 3 and 7? 0. Negative 7 times 3, if I were to plug in 0 for my x's, is negative 21. Is negative 21 less than or equal to 0? Yes. I'll tell you another thing. Is if it doesn't have a denominator, that means it's just a polynomial. It's nice and fluent, which means these are going to have to alternate. You don't have to worry about that. We could just check all of them. Negative 7 times 3. See, I plugged 0 in, and I got negative 7 times 3. I got negative 21. What's the number less than negative 3 we can check? Negative 4. You plug in negative 4. Negative 4 minus 7 is negative 11. Negative 4 plus 3 is negative 1. What's negative 11 times negative 1? Is 11 less than 0? No. What's the number greater than 7? 8. If I plug 8 in, you get 1 and 11. What's 1 times 11? Is that less than 0? Very good. So our answer is from negative 3 to 7. Now I'll tell you this. On your test, this is how this answer looks on your test. They literally stick with the number line, except they do it like this. See how it's a bracket? That's how that'll look on your test, except they won't have the x's in the checks. Negative 11 times negative 1, which was positive 11. No. That's a good question. Any of these today, any of them, once you find what makes them equal to 0, you may have to use P over Q's. You may have to use quadratic. You may have to use anything you know how to solve a function. But whenever you find what those numbers are, you're going to do a number line. Every time. You plug in numbers on the given intervals. We plugged in a number between these and on either side of these. And we got x's and checks. And this was the only interval that worked. So that's why negative 3 to 7 was our answer. Now, the only difference between number 3 and numbers 5 through 17 is that it's not prefactored. Number 3 was prefactored, the others are not. Only difference. 5 through 17, we just have to find them ourselves using the quadratic formula. Let's look at 17. 17. What is the easiest way? Oh, yuck. I have more stuff down there. What is the easiest way to put all of this on one side of the equation, which should always be your goal? Very good. Just go ahead and move the 5x. So 0 is less than or equal to negative 3x squared minus 5x plus 2. I just subtracted the 5x to the other side. At this step, don't even worry about the inequality. Just solve the dang thing. Let's plug it straight into the quadratic. Negative b plus or minus. I could never make this song sound right. Yes. Quadratic formula. Well, I appreciate that. The quadratic formula? Negative b plus or minus b squared minus 4ac all into a radical over 2a. Okay, here we go. 25. Now this is a minus a negative, so it's going to be plus. 4 times 3 times 2 is 24. 25 plus 24 is 49. What's the square root of 49? Over negative 6. Okay, 5 plus 7 is 12. What's 12 over negative 6? Negative 2. 5 minus 7 is negative 2. What's negative 2 over negative 6? There are your numbers. That's what you're putting on your number line. What did you plug in the calculator? Oh, that's right. But it's 25 plus 24, which made it 49. Okay. So that's negative 2, 1/3. What's the most logical choice to check? 0. Plug in 0. I'll just plug it into this one. That's going to be 0 minus 0 plus 2. Is 2 greater than 0? Yes. Who has a prediction about what these other two are going to be? They're going to be x's. Because think about this. You know this. Look at this. Do either of these occur twice? No. So if I asked you to describe what they're going to do on the graph, what would you say? They're going to cross, which means you're going to go from satisfying this to not satisfying this. Now what if you would have the negative 2 twice? What if negative 2 had been a double? What does that do on a graph? It means it touches, which means you should have the same thing on both sides because you never actually cross. Things like that. There are tiny little clues buried throughout these problems that can help you make logical deductions about your answers. So if you plug in a number less than negative 2, it will not work. Plug in any number greater than 1/3, it should not work. Thus, your answer is negative 2 bracket to 1/3.
So when we're plugging in whatever number we're just looking to see if it's greater than or less than 0.
You're looking to see if it satisfies the equation. I would also recommend you always use the one that you use setting it equal to 0. It's going to be easier than going back to the original, in my opinion.
Tracking the private numbers.
You mean after I found that to be a check with a 0? We just discussed it. The safest thing to do, Latifah, right there, which I did not do on this problem, but the safest thing to do would be now to check a number on this side and on that side, and you should get that neither of them won. Now, another reason that's the safest thing to do is because the next slide we're going to start taking in, well, no, we're not apparently. In the future, we're going to be taking vertical asymptotes into the equation, in which case they might not be alternating. But these are all the exact same thing as what we just did. Somebody take a look. If you think one looks particularly hairier than the others, we can discuss it. Why does 33 look worse? Let's make that equal to 0. 7/2. Let's make this equal to 0. Twice. 2. Twice. Which means, what do you think is going to happen around the 2 on the number line? It's either going to be check, check, or x, x. It's not going to change. Let's look at 33 real quick. I'm just going to put it straight on the number line. And I bet you around the 2 we're going to have a check check or XX. 2, was it 7 halves, which is actually greater than 2? 7 halves. Okay. What's the number less than 2? We'll just start on that interval. Really? Nobody wants to try 0? Okay, fine. 1 it is. 2 minus 1 is 1. 1 squared is still 1. So 1. 1 minus 7 halves is negative 5 halves. What's positive 1 times negative 5 halves is a negative number. Is a negative number less than 0? Yes. Check. Now, using our logic, we're predicting there's going to be another check right after that. What's the number between these two? 3. 2 minus 3 is negative 1. Negative 1 squared, positive 1. 3 minus 7 halves is negative a half. 1 times negative a half is a negative number. Is a negative number less than 0? Yes. What about at 7 halves? That one only occurred once, which means it crosses. So what do you think that last one's going to be? An X. Well, let's check it. Let's try 4. 2 minus 4 is negative 2. Squared will be positive 4. 4 minus this is a positive number. Positive times positive is going to be not less than 0. So X. It doesn't really matter what the numbers are. Since all you're looking at is if it's positive or negative, one thing you could do is 2 minus 4 squared is going to be a positive. 4 minus this is a positive. That'll be a positive. Is a positive less than 0? No, it is not. What were you saying? That's right. That's right. Actually, I think you have that flip. I think it's going to come up and then go up. What? In logic, I see what you're saying, and yes, you're right. What? On the test? Here's what it'll look like on the test. Is there an equal sign? So it's a soft parentheses to infinity, because it kind of encompasses all of that. The way I would write it today is just negative infinity to positive 7 halves. Good question. What are the 3 numbers that are going to make that equal to 0? 0, 3, and 5. And then you just check. On that one, some of them today, and I apologize, you're going to have like 4 numbers on the number line. You have to check all those intervals. That's where the most tedious thing of the day. Now, I know I won't be here tomorrow. We're not done yet, but I'm just throwing this out there. I will take questions on this Monday. If you do not wish to turn it in tomorrow, I will take questions on it Monday. That does not mean you should procrastinate, because it's going to be on the review tomorrow. Okay, so Monday I'll take questions on this, assuming everything goes well, and I'll go over some more review with you, and then Tuesday we'll test. Okay, all of these are pretty much the same. When you get down to these, notice they're cubes. You're going to have to do your P over Q list and find one that works, and then use quadratic, just like we did the last few days. And then those numbers you're going to put on the number line. Where it gets a tad hairier is when you have fractions. And actually it's not, it just looks different. Look at 43. What's going to make the denominator equal to 0? Negative 3. Now, everything we've done this year with fractions, that's all you had to look at, right? The bottom. Top didn't even matter. Well, the top matters now, because what's going to make that function equal to 0? 4, which will give us 0 over a number, which means it's going to cross the axis. So the 2 numbers you need to try in your number line on this one are 4 and negative 3. What about number 49? What's going to make that part equal to 0? 2. What's going to make that part equal to 0? A little harder. So negative 4/3. To set it equal to 0, subtract 4 divided by 3. So 2, negative 4/3, number line, same thing. The only difference is you have to check top and bottom. But it works out the exact. We'll do one. Let me look at the next slide, see if there's any harder than that one. What about 53? Negative 4, 1, and in fact, that'll be the one that works. I'll scratch these off since it's kind of last minute. When it doesn't equal 0, it's a tad harder. We're not going to worry about that right now. Let's look at 53. Oh man, my border is not white anymore. So, on my number line, -4, -2, 1. Now, one of these is an asymptote, so all bets are off. You actually have to try all your intervals. What's the number less than -4? -5 plus 4 is a negative number. -5 minus 1 is a negative number. -5 plus 2 is a negative number. What's a negative times a negative? What's a positive divided by a negative? Is a negative going to be less than 0? What's the number between these two? -3. -3 plus 4 is positive. -3 minus 1 is negative. -3 plus 2 is negative. Positive times a negative? Negative divided by negative is a positive less than 0. What's another number between -2 and 1? 0. That'll be positive, negative, positive. What's a negative divided by a positive? I'm getting lost in all this. I know it's easy, but it sounds... I get it. Okay, forget it. What's a number greater than 1? 2. That'll be a positive, and a positive, which will be not less than 0. And there's your answer. More or less. When you can do that when it's being compared to 0, which you can make happen on every problem just by moving stuff over. Because when you're comparing to 0, all you really care about is positive or negative, right? Well, that one has an asymptote. So that one actually has an asymptote at -2. What? I'm sorry. My speaker died. I don't have any more like those rectangular battery things. So, but since you asked, this is what this would look like. It crosses at -4. It crosses at +1. I'm way too lazy to find the y-intercept, but it probably has one. And it's going to have a vertical asymptote at -2, which means, oh, sugar. I don't know what the behavior is off the top of my head. But it's probably, if I had to guess, going to look something like this. And then come in from up here like that. That'd be my guess. Good question. Excellent question. Because can you equal 0 in the bottom? No. Which means around the -2, you have to have a parentheses. However, let me do this in a different color. However, the actual problem has an equal sign, so everywhere else there will be a bracket. So that's -infinity to -4, bracket, but then -2 to 1 will be parentheses, bracket. Good question. Because it can't equal -2. What? Yes. Every asymptote will have a parentheses. Even if it cancels with something on the... That won't happen today. Just forget that I said that. Does it say to graph these? I don't think so. No, you don't have to grab them. If you can, that's like we talked about earlier, that can be an easier way to do it, but you don't have to. Questions? Yeah, that was a fun lesson. Okay. Don't worry, I'm going to change these. Well, I'm only changing it by one problem. There you go.
What section?
You have the right to ask. This is section 2.7. That's so funny that you